Welcome to this week's research overview. It's on line plots, interpreting, constructing, understanding line plots. And you might be thinking, why would line plots be important? Well, it is for grades 2 through 5 within most state standards, but more importantly, understanding data is so needed right now because of all this information coming in on social media, on news, podcasts, whatever we listen to. You need to be able to understand data because there's lots of misinformation as well as good information. So let's jump into line plots. I'm Dr. Jonathan Brendifer from the Developing Mathematical Thinking Institute, and here we go. So with line plots, there's actually 4 major misconceptions. But to start before that, let's take a step back. When we're thinking about data, what is data? It's simply just information coming in. We're going to collect this information somehow, and then we need to interpret it, we need to display it first and then interpret it. So one of the first things that we do when we have information is we want to be able to get the data and look for its shape. So where does it have a center? So a lot of times we think of like a bell-shaped curve. Does the data all clump in the middle? And then how far does it spread out, this range idea? So those are some really important big ideas no matter what the data are. And then there's another thing called categorical and measurement data. So we're going to talk about both those in the light of line plots. Okay. So one example, we're going to jump right into grade 2. It's always really nice to have a good, realistic situation. And when we're collecting data, we want to have a question that you actually collect data. So it's not asking the question is, what is your birth date? That's one piece of information. But we're going to be asking a question like, for this second grade class, what are the most common or typical color shoes? So now we can walk around, we can collect the data, we'll ask every kid, what color are your shoes, and we'll collect that. So let's say we did that, and so that's categorical, so these are categories, and we might get 4 categories. Red, black, white, and blue. Those tend to be the most common if you're in second grade. And so then we're going to use a bar graph to display those. So that has a frequency. So we're going to say, let's say you had 3 red, then we're going to have another category, white, 4 black, 8 blue. So then you can ask questions. What is the most typical color of shoe? White. What's the least? Red. You could ask other questions like, what about purple? Did we not collect it, or no one in the class had that? So those are categorical. Now, we could rearrange those categories. It doesn't have to be in the order that I first said. We could rearrange them because they're just categories and it does not matter. So that gets us into line plots. I want to be able to talk about bar graphs because a lot of kids and teachers will be dealing with bar graphs, but then they'll move into line plots and think they're the same because there's this frequency. Okay, let's jump in. Okay, one of my favorite ones for second grade is just asking the question, what would be the most typical number of pockets that a second grader has? So we can look around, go 1, 2, 3, 4. So my name, and it's 4. And then we can go around the room asking people, I have 3, I have 0, I have 6. Little side note, I was doing this up in a ski town one time in the winter with second graders. They had all their coats and their ski pants, and the numbers for second grade were 18, 24. I was like, oh my gosh, numbers were a little bit too big for second grade. That might be great for third or fourth grade. So just depending on where you are, asking that question. That was a funny one for me because I was shocked because kids were struggling a little bit with the bigger numbers. Typically it's between 0 and 7. Okay, so then what we want to do is we typically use an X to represent each data point. So if there are 3 pockets, then we count up how many students and we put X, X, and that becomes a frequency. So we might have 5 X's, which represents 5 students. All have 3 pockets. The other thing that's important is you're going to construct it on a number line. So here in this case, we are going to have a number line that's between 0 and 7. Now, one of the misconceptions is, well, what happens if there was no one with 6 pockets? That still needs to be represented, even though a lot of students will skip it. Like categories with the bar graphs, they'll just put 0, 1, 2, 3, 4, 5, skip 6, and put 7. But measurement data, each data point represents, we have to have all those data points. So even if there are 0 6s, that's still an important data point. So that is that category that we need to describe. Another misinterpretation is Are we counting the number of categories? Or are we counting the frequency of the number of X's? So those mean two different things, and students will misinterpret those all the time. In addition to that, we could say that each X represents 2 pockets. So now that starts changing the data a little bit too. So there's some misconceptions with those data points. And here, you can't change. So even if we had a lot of pockets at 3, very high, and a lot at 6, you might say, can we just rearrange those? Nope. Order is very important with measurement data. So on that number line, every item is represented. So those are some of the misconceptions for the categories, the frequencies, what each X represents, and misinterpretation that these are categories that can be swapped out like a bar graph, which they are not. So that kind of gives you a little bit different on whether we're collecting measurement data or we have categorical data. So 2 different ways of displaying it. So with 2nd grade, we want to do numbers under 10, so that's why the pocket is a good example. By 3rd grade, you want to get larger numbers. You could ask for how many books have you read this year? And so, or something like that, where they're collecting something maybe in the teens. By 4th grade, it'd be with fractional data. So we might ask, let's collect all these pencils, and what are their measurements to the nearest ½ inch, nearest quarter inch? So that changes it. And then 5th grade, same thing, but now we're going to be adding and subtracting categories. So if we added 2 categories together, what would be the total number of pencils? Or subtracting different amounts. So that's a really important idea there as well. So now that we just mentioned all these examples, we are going to have those in the link below. It'll take you to our website, and we'll have these options so you can try them out in your classroom. So we'll have a couple 2nd grade with both the bar model and the line plot, and we'll have one for 3rd grade, 4th grade, and 5th grade. So you can try out. I'm also going to be putting in some questions that you should be asking that will get at these different misinterpretations or these misconceptions that the students have. So this is a really fun one for you to try out. And all of these are downloadable PDFs that you can print out. So if you thought this was interesting, please share this with other people, parents, and other teachers. Please like and share this, and follow us for more information and more ideas.